Find the error in the following solution to the problem. Explain the error. Then solve the problem correctly algebraically, represent it graphically, and using interval notation. So, in this process, I could either go through each step and try to see where the error is, or I could first start showing it algebraically and see if I have an error. So, the first thing I'm going to do is start showing this algebraically to see how my process might differ than the one that's being shown. So here in this scenario, what I would do first is probably distribute the -3 into both parts of the expression. So we have -3x minus 6 is less than or equal to 9. And now I'm going to solve this inequality by isolating x. So I'm going to add 6 to both sides. These would cancel out. And we would get -3x is less than or equal to 15. Now remember, the sign will change from less than or greater than if we multiply or divide by a negative number. But here we added a positive number, so the sign did not change, so we're good. So -3x is less than 15. But now, on each side, we're going to divide by -3 to isolate x. These will cancel out. And since we're dividing by a negative, the sign is going to change. So it's going to change from being less than to greater than. And 15 divided by -3 is -5. So I'm just going to highlight here that it changed from less than to greater than because we divided by a negative. So after looking at the correct solution and how we would do it, we can go back to the student's work and see where the error was. So in this step here, in the first step, we see that the student divided both sides by -3, and this is totally allowed. So instead of distributing, we could have divided each side by -3 and avoided distributing. This is absolutely correct. But the issue here is that they divided by a negative. One second. Okay, so they divided by a negative. It's not letting me write. Hang on. All right, here they divided by a negative, but they didn't change the sign. So the sign did not change at all. So if we see here and here, the sign stayed exactly the same, even though they divided by a negative. And here's where the issue would lie. So if they had switched from a negative to a positive not from a negative to a positive, if they had changed it for x plus 2 is greater than -3, and they subtracted 2 from both sides, we would have been left with x is greater than -5, which is the correct solution. So the error here is that the student did not change the less than symbol to greater than after dividing by -3. The symbol changes when multiplying or dividing by a negative. All right, so now on our inequality number line, we want to graph that the number is greater than -5. So here we're going to go with an open circle because this would not include -5. If it was greater than or equal to, then we would make it a closed circle. And it's going to be greater than -5. So we want to go the direction in the arrow is going toward all the numbers greater than -5. So this is going to go toward infinity. So in interval notation, we would write this as open bracket -5, comma, to infinity. And infinity always gets an open bracket. So this is because we had an open bracket. And here we have an open circle. And that is because it does not include -5.